The next presentation will introduce the SDAC chapters of the annual report. The speakers will be Chiara, Vitelli, Martina, Gabriel, and Miha Pregl. Miha, the floor is yours.
Thank you. Thank you, Kata. Thank you, Rafael, for the introductory words. Thank you to all of you joining our webinar, and especially welcome to our day ahead part, dedicated part, where our experts, Chiara and Martina, will present the main features and 2020 data related to single day ahead coupling. Kata, if we can go to the next slide. So in 2020, as already mentioned by Rafael, most of European Union were covered by the single day ahead coupling, where 16 NEMOs, in cooperation, of course, with TSOs, ran successfully all 365 market coupling sessions. In that period, I would like to mention two important events. First one I would like to point out is the geographical extension in the end of last year, the inclusion of Greek bidding zone in December, which basically extended the single day ahead coupling almost to the end of our geographical area. Second important event happened actually in the end of the year. It was an unfortunate event, of course. We were used to extend our operations, but we successfully excluded GB due to the Brexit from the operations. Nevertheless, that 2020 was highly marked with pandemia. The economic dimension grew by 3% to the 1,500 terawatt hours, which is in total consumption approximately 62% of overall consumption of European Union. So significant amount of total consumption in our European Union is covered by trading on single day ahead market. And our daily averages are around 4 terawatt hours. It is interesting to present also the annual average clearing prices, especially these days where we are seeing the records, and I'm sure that next year with similar webinar we'll have an interesting discussions. But in 2020, the average clearing prices in comparison to 2019 declined, of course, mainly due to the pandemic situation. And you can observe all the details in our report. So this will be all from my side as introductory words, and I'm leaving the cockpit now to our two experts, Chiara and Martina. And thank you for joining again, and enjoy the flight.
Thank you. Thank you, Miha. If we can go on, Kata, perfect. I will just briefly introduce the operational report, which deals about all the operational events which happened in 2020 in SDAC, namely the incidents, the request for change, and the corrective measure. I anticipate here that no corrective measures were triggered in 2020 as well as in the previous year. In any case, all the detail about this operational report can be found both in the CACM Annual Report and also in a dedicated Excel file which is published in the NEMO Committee webpage. But just for now, just have an overview of what happened. So in the next slide, we can start with the incident. Please, Kata. Thank you. So starting with the incidents, we see that unfortunately the number of incidents increased in 2020 with respect to the previous year. Despite that, the great majority of the incidents, both in MRC and for MNC, were or not even visible to market participants, or were incidents which didn't lead the sending of the message of partial decoupling. Unfortunately, one incident is classified as severity 1 because it led to partial decoupling. But what is important to state here, and also Peter anticipated it at the beginning, the cause of this incident, as well as the causes of all the other incidents which have been registered in the MRC perimeter, were not related to the NCO asset or to SDAC procedure. Instead, they are related to technical issue at the single NEMO level. And if we go to the next slide, we can have an insight about the decoupling incident of the 4th of February. In this case, the technical issue was at Nord Pool level. This issue was triggered by ENCO local trading system inability to successfully aggregate purchase and sales cubes. This prevented ENCO from submitting the aggregated order book to the central market coupling process in due time. And for this reason, 3 interconnectors were decoupled. The common coupling system worked as expected and ensured decoupling for the remaining part of MRC. Of course, the Joint Steering Committee initiated an in-depth investigation in order to identify the lesson learned and the risk, and in order to mitigate the risk for similar incidents to happen in the future. Also, in this case, the in full investigation report has been published timely on the NEMO Committee webpage, and you can find there all the information. For now, just go on and have a look to the RSCs, because in 2020, also the number of RSCs increased with respect to the previous year. We had many RSCs, many challenging RSCs, and in the following slide, we'll have the complete list. We can refer just to the most challenging ones. We had 2 go live of 2 M&As, the Nordic M&A in June, but also the NordNed M&A in November. We had the go live of the Allegro cable in November, and also 2 system releases, Eufemia 10.4, which went live in June and implemented network constraints and parallel line features, and also Eufemia 10.5, which went live in December, implementing LTA inclusion. And last but not least, we have to refer also, as Miha said, to the incorporation of Greek bidding zone into the SDAC. And unfortunately, yeah, the hard Brexit at the end of the year. Now, the question is, how do the algorithm react to this increased complexity coming from so many challenging RSCs? The answer of this question can be found in the performance monitoring report. Also here, I will have just an overview of what happened. And in a nutshell, we can say that during 2020, the performance of the SDAC algorithm continued to be highly positive. The usage of the products, with some exception, punctual exception related to single products, but on average show moderate growth with respect to the previous year, which is about +9%, which is in line with the trend registered in the previous years. The time to first solution, despite the implementation of growing number of RSCs and despite this increase of usages, show an improvement and a reduction with respect to the previous year, around -6%. And the average annual time to first solution was around 3.2 minutes, which is well below the 12 minutes allowed to the algorithm to run. Let me say that this achievement was made possible thanks to the R&D, which allowed the algorithm to tackle and solve more complex problems in less time. Also, for optimality and repeatability, they continue to show the good performance we have registered in the previous year. And now we can have an insight on these performance indicators, just to have, thank you, some more information. Also looking at the monthly trend of this indicator, we can start with the indicator which measures the ability to maximize the economic surplus. The first indicator measures the increment of economic surplus with respect to the first OK solution. We see here that the maximum increment along the 2020 is at the maximum equal to 500 kilo euros. This, of course, is a negligible contribution if we compare this with the 9 billion euros of daily average welfare, which has been registered in 2020. And the same result is confirmed also by the second indicator at the next slide. Yeah. This indicator measures the economic, too fast. Okay, here. The previous one. Okay, thank you. This indicator measures the gain after increasing the calculation time by 10 minutes. And also here we see that the variation is quite negligible because it's bounded by plus minus 300 kilo euros. And also these results compared with the 9 billion euros can be considered negligible. If we now go to the next slide with here with the most important, let's say, performance indicator, which measure the algorithm scalability by measuring the time to first solution, we see that also looking at the monthly value of the indicator, we see a reduction in time to first solution with respect to the previous year. And as I anticipated, with the go live of Euphemia 10.4 in June and Euphemia 10.5 in December, we had an improvement of the time to first solution, and the algorithm was able to absorb the complexity mainly related to the two M&As go live and to the go live of the Allegro variable. If we look at the picture of the if you look at the picture of the duration curve, you see that also in the most challenging sessions, the highest value of time to first solution amount up to 7 minutes, which is well below the 12 minutes, but this is also an improvement with respect to the most challenging time needed in the past few years, which were around 10 minutes. And I repeat myself, but of course, this achievement was made possible thanks to the R&D, which allowed the algorithm to tackle more complex problems in less time. And now let's go to the last family of indicator, the performance indicator, which these are two indicators. The first one, which measure the repeatability of the algorithm. The first one is the repeatability frequency indicator. In this case, the higher the value, the better the repeatability. And we see that in 2020, the repeatability measured against the most important values is always higher than 98%. And if we look at the duration curve, we see that for the great majority of the session, we have that this repeatability is equal to 100%. This good result is confirmed also by the second indicator, which measures the repeatability at the following slide. Thank you. Here we have the repeatability impact of difference indicator. In this case, the smaller the indicator, the better the repeatability. And we see that also in the most challenging session, the maximum discrepancy among the relevant values is not always lower than 500%. And also in this case, if we compare the duration curves of this year with respect to the duration curves of the previous year, we see an improvement. Now, if we go to the very last slide of this part, here we find the individual impact of performance analysis, which has been performed following what is stated in Article 8.3 of the ALGO methodology. This analysis is performed for all the products included in the day-ahead product methodology, apart from stepwise curve, simple blocks, and merit order. All the remaining products have been replaced by the most similar alternative product, following, of course, the specific conversion rules. And this simulation, all these simulations have been run with a batch coming from an historical dataset from Q4 2020. We have the results in the table. By rows, we have the products tested, and they have been compared with the reference scenario with all the products in. We have measured the average time to first solution in each of these scenarios, and we compared it with the average time to first solution in the reference scenario. What can we say about the results? We see here that also in the most challenging cases, the maximum gain we can have by removing one product is of the order of few tens of seconds. So for this, we cannot say that we can say that no single product can have a standing alone key impact on the algorithm, also considering that this methodology overestimates the impact of the products over the performance of the algorithm, because by removing one product, we are not only removing that product, but also the interaction among that product there and all the others. And it's from this interaction that most of the complexity for the algorithm arises. Then another thing that it's important to stress here is that this methodology is heavily dependent on the assumption done on the conversion rule used. So if market participants would behave in a different way in case we remove one of the products, of course, the impact of the product changing the conversion would change the impact. And last but not least, we should also underline that this year we found, with this methodology, we found some counterintuitive results. For instance, if you look at the result of the piecewise curve, you see that from the simulation, it seems that when we replace the piecewise curve by stepwise curves, instead of having a reduction in time to resolution, we achieve an increase by several tens of seconds. How is this possible? The reason may be several. First of all, there are some internal parameters of the algorithm, such as the simplex or the heuristics, which have been optimized in order to perform well in a great variety of situations within the reference scenario, so with all the products in. In case we remove one of these products, maybe we should reassess against all this variety of situations the internal parameter of the algorithm. And second, another cause could be the batch. This year we increased the batch in which we tested the simulation. Last year it was only 1 month. This year we increased it up to 3 months, coming from the most challenging quarter of the year, the Q4. But this could not be enough. Maybe we should extend it in order to have more conclusive results. And last but not least, we should also remind that also the size of the single session inside the batch has its importance, because we have seen that passing from one session to another, we achieve very different results, also by order of magnitude and also by signs. So for all these things I stated, it's clear that this exercise has been accomplished also in order to comply with the regulation. But of course, these results should be handled with care, because you see, you can also have, as in case of the piecewise curve, some results may not be so reliable. So in order to make any decision coming from the study of the impact of products, we think that maybe we should reconsider the methodology followed in order to have more reliable results. Of course, NEMOs and TSOs will work on that, and as usual, in close cooperation with ACER and ERASE. But now I can stop here. I thank you for your attention, and I leave the floor to Martina for the scalability and R&D report. Thank you.
Thank you, Chiara. Good morning, everybody. I'm happy to present you the Scalability Report and the R&D report for the SDAC part. The Scalability Report is defined in the algorithm methodology, and it shall assess the impact on the performance of the algorithm of implementation of different requirements, different requests for change on one side, and on the other hand, impacts on the anticipated usage of products. That is how the scenario are built. For the years 2022 till 2024, the demand for scalability is expected to increase significantly. This is due to many requests for change, which are planned to go live in this period. To name some of them, you have the extension of M&A to Nordics and Baltics, you have the extension of the flow-based approach to the Nordic and co-region, for example. And you have also the exogenous growth trend in the usage of products. This year, Scalability Indicator unveiled more performance challenges compared to the last year. one of possible explanation is the application of the growth, the methodology. We added 1 more year of growth compared to 2019 report, so we have 2 and 4 years, 2022 and 2024, and it can, on the other hand, come also from the fact that for the reference growth, the one between 2019 and 2020, some of values were unusually high. So if we then apply them to other scenarios, we indeed continue with obtaining high values. You will see in the other section that this topic of performance is closely linked with the R&D work, which works on the constant improvement of performance of the algorithm and also of its robustness. We can now, I think, pass to the next slide where you will see the concrete results. As I said, the scenarios were built out of requests for change, anticipate usage of products, and what was used also within the simulation is different configuration, not necessarily the default configurations of the algorithm. These are the solutions which can be used operationally in case the algorithm provider needs to intervene. Looking on the graph on the right side, so first you have the red flat line. The red flat line is the 17-minute time limit we have currently in production. Then we have the blue graph, which represents the average time to first solution for the 2020 year for the MRC part. And you can see it was 3 minutes and 13 seconds. The other 3 curves are related to those scalability scenarios which were performed. So first, if we come from the dark orange color, you can see the 2022 forecast, which included, for example, core flow-based, Nordic flow-based, and indeed the anticipated growth of products which go with. We come to the time to first solution of 9 minutes and 41 seconds. For the second scenario, which is the projection for 2024, with in addition scalable complex orders and again the increase in usage of products, we obtain the average time to first solution of 17 minutes and 33 seconds. That's the green curve you can see on your screen. Finally, the third scenario was the one again for 2024, but to which we added also the implementation of 15 minutes granularity. Here we are finishing with average values of practically 2 hours for the time to first solution, and for some sessions there was even no solution even after 5 hours and 30 minutes. It is to be noticed that those simulations were performed with the UFIMA 10.6 version, which cannot yet deal with NEMO volume problems, so the volume problems were deactivated. So these results are, let's say, preliminary results as for the version available. We can, on the next page, we can see again the detail of the graph, and you can see how exactly the average time for solution for different scenarios was positioned. And you can see also the 2 small radars, which showed you the content of the scenarios which were used. On the graph above is the increase of the usage related to the topology, which was foreseen in each simulated scenario. And the radar below is the one concerning the usage related to products. Here it could be an example of the application of growth factors, which I mentioned. You have here a big difference for the PUN orders between the different scenarios. This was the case of the situation where between the 2019 and 2020, the increase of the orders was very important. And so we continued indeed to apply, as the methodology requires it, apply this growth factor also to the following years. So this was the presentation of the scalability report. You can see that there are still performance challenges, and you can see that the result is also highly dependent on the growth factors and hypotheses we use to bring answers to those performance challenges. We have the work performed within the research and development section, which is the last report to be presented in this section. So I would just ask you please to go there. Thank you very much. As you know, this R&D program was launched in 2019 in order to guarantee to Euphemia a constant development and timely adaptation to the regulatory requirements and market evolution, while improving as well the design as well the performance. After 2 years, we have already tangible results. The optimality gap was considerably reduced, the performance was increased, and we have also new features which were already implemented into Euphemia, like into LTA inclusion, complex order first, or scalable complex orders. To give you a first figure on the improvements, we consider that for the Euphemia 10.5 improved by about 15% over the Euphemia 10.4 as for the average time to first solution, and we expect this performance increasing in next releases also. In addition to this research and development work, which is led in the Euphemia lab, the NEMO Committee launched in 2020 also an open call for papers in order to gather new and challenging ideas on the evolution of the algorithm. The contributions were assessed, and some of them were already presented early this year in a March workshop, and maybe in the future will be further analyzed within the Euphemia lab. If we can now, we can go to the next page, please. I will present you the most important outcomes of the 2020 work. You will not be surprised to see on the first place the 15-minute implementation, 15-minute MTU implementation, as it is a key topic. Why is it so important and demanding? Because on one level, you have all the work concerning the adaptation of functionalities. You need to adapt functionalities, the interface, etc., to be ready to handle with the 15-minute granularity. The second part of the work is to adapt the performance. As for the functionalities, I'm happy to say that all core functionalities are now introduced in the prototype. As for the performance, there were improvements achieved, but indeed it is still work in progress. Why it is such a challenge for the performance? Because with 15 minutes granularity, you have 4 times more data, at least, but in the same time, for the algorithm, it means that the complexity will increase exponentially. So that's why we need to continue to work on this aspect. And one of possible solutions is the next topic presented on the slide, which is the distributed architecture. Today, Euphemia is using one machine and with running on several cores in parallel. The distributed architecture consists on using different machines, several machines in parallel, which shall increase the performance and decrease the time to first solution time. The concrete gain will then depend on the hardware choice of the hardware which will be implemented. Another outcome of the 2020 work was related to market product improvements, concretely the PUN orders. On the next page, you can see an overview of improvements which were achieved. Just please pay attention to the fact that to interpret correctly those results, we always need to take in account what was the batch and data used to perform those simulations, what was the version of Euphemia, and what were other conditions. For those 2 graphs, some constraints were removed. So it is not really a production-like environment, but let's say rather laboratory conditions. We can see that on the left graph, as for the red, which comes from February 2020 using the 10.5 prototype. On the red part, you can see that the average time to first solution was more than 50 minutes when we used the batch with 15 minutes data, simulating the situation of Big Bang implementation, so meaning that 15 minutes are implemented in the whole SDAC. On the right graph, it was already a more advanced version of Euphemia, which was used. And you can see that with the 15-minute network with adaptations and usage of scalable complex orders, the average time to first solution is about 15 minutes, the maximum being 22 minutes. But with the attention point that for example, LT inclusion and the NEMO flow and financial exposure calculation is not included. And here the batch which was used considered the stepwise situation. So one, for example, first wave implementation where the whole SDAC is not yet switched on 15 minutes granularity. On the next page, we can briefly observe the distribution of the workload within the iterations, because the work on research and development is organized in 6 months sections, 6 months iterations. For 2020, it was the iteration 3 and iteration 4. And you can see that if you are speaking about 15 minutes topic, about distributed architecture, about PUN orders, you can find those items also in the workload distribution. And for example, for 15-minute topics, for both iterations, you have more than 40% which were dedicated to the topic. That's the green part on above with the 15-minute NTU prototype, and then the blue concerning the different dedicated scalability improvements, so altogether more than 40%. I think that indeed you can then check the report for more detailed information. Now we will switch again to the next page, please. To look also a little bit into the future, because these were the outcomes of the past years. And so the question is also what will be the next steps and what is the work in progress, because especially the performance challenges are still here. The short-term target will indeed consist in finalizing the functionalities for the 15-minute MTU implementation. Then also still the work on the performance improvement. It is possible that outcomes of the call for papers may also be an object of the further research. Speaking about the improvement of performance, we shall also further analyze the potential of the so-called non-uniform pricing, which is an approach that has a big potential of increasing performance. The other side of the performance is that we might need to, in some case, to apply some corrective measures if performance is degraded. So that's why this topic of corrective measures will be also the part of the scope of works within the research and development. In addition, there will be indeed new topics which will appear, like, for example, the co-optimization, and again, some research and development work will be needed. So to close this report, indeed, we can expect in long-term perspective other requirements, market growth, and increasing complexity. And indeed, Euphemia needs to be able to satisfy those requirements. So further research, including disruptive approaches like non-uniform pricing, is indeed needed. Thank you for your attention, and I'll be happy to give the floor back to the cockpit to Stefano, I think.
Thank you, Martina. Thank you, Chiara. Thank you, Miha.